Good evening, everyone. I doubt we have someone in the US side to say good morning. It's a pleasure to have three pyramids in the tech industry with us today. So happy to have them in the first time for a VMUG Egypt. And in Egypt we say it's a joke to introduce them. This is the translation of one of the common saying in Egypt. It will be like something funny, and people will laugh if I start introducing who is Duncan, who is Cormac, who is Frank, because everyone in the industry knows them very well. And we are happy to have them in our session today. And we want to get the best out of it. So we will not do any more introduction. We will hand it over to Duncan. So we start. Feel free to put any question on chat, even if you want to put it in Arabic, and we will be happy to translate it and get you the answer. With that, I will hand it over to Duncan to take it over.
Well, actually, I'm going to start. So, but doesn't matter.
No.
It's actually a great honor to be called the pyramid, to being compared to something so great. So awesome. Let me share my deck. Hi everyone, my name is Frank Denneman. I'm a chief technologist in the office of the CTO of the Cloud Platform Business Unit. We're responsible for the core products such as vSphere and vSAN. And I'm opening up this roadshow. Now, throughout the roadshow, we would love to interact with you. So please, if you have a question or you want to raise something, use the chat functionality or wait for the Q&A after each session. So during the presentation, one of the presenters will likely answer the question in the chat, but sometimes the presenter itself will pick up the question and answer it straight away. So don't be hesitant, don't be shy, just ask away in the chat function. So during my session, I'm going to talk about the introduction of containers in your data center. And after that, I would like to look at how to create a platform that allows developers to use the platform without the interaction with you. And then the third topic is the consumption strategy. How can you create an environment that a developer can safely consume while you are still in charge running your environment safely, securely, and efficient. So let's talk about how containers might enter your data center. So what we see when we talk to customers is that containers will slowly appear in their data center. And one of the things that containers are replacing is commercial off-the-shelf software. It's basically the software that you install by downloading the files or maybe even using a DVD. Now, we're not the only ones who've been seeing that. One of the analyst companies, IDC, they created a report, and in that report, they made this prediction that over 500 million cloud-native applications are expected to appear in the enterprise data center over the next 5 years. Now, 500 million applications, that might sound like an absurd number, but if you look at the current or modern paradigms, development paradigms, or new waves of applications, then that number isn't really that strange anymore. So let's use machine learning, for example. When you do machine learning, you generate a lot of data, or you collect a lot of data, and you extract that data from multiple sources, you transform that data, you select that data into, and you put it into a machine learning model. You run it on an accelerator, and then you analyze the predictions, or you might even use that model in a production type application. Now, throughout these steps, those are we typically use a container-based application to guide these steps throughout that pipeline. So a typical machine learning application, what we see, usually generates about 30 to 40 different types of containers. So if you take that as an example of just one machine learning application spawning up to 40 containers, it doesn't make that number of 500 million apps that weird, or 500 million containers. So now, one of the things that we notice is that you might not have a developer, or you might not have interest in machine learning at the moment. So is this prediction still true for you? Are you going to see containers in your data center? Well, what we noticed is that there are a lot of software vendors looking at containers as a distribution method to provide or distribute their application to their customers. And another analyst firm, 451 Research, generated a report showing that of the 214 software vendors they tracked, a lot of these vendors are pushing containers as a distribution method. And one of the most famous one is SAP, who provides the new functionality of their enterprise software as containers in their environment. So even if you don't have a developer in-house, chances are you're going to see a containerized application in the next few years. So when we think about that, we think about the introduction of containers and virtual machines and all of these things with relationship to the vSphere platform. We want to take a closer look to a modern application architecture. What is involved? What do you need to have in order to run such an environment? And what we see is that the majority of customers are focusing on newer services to deploy in containers. So let's take a bank as an example. And now that bank might want to deploy a particular online banking service. So what they do, they use their developers and they create this containerized application. Well, this containerized application is typically a distributed application, meaning there are more containers that actually make up the entire application. So instead of having one container, you have multiple containers. And in order to ensure that these containers start up properly in the right order, or if something happens, they get restarted, they get their required resources, all these things, you need to have a form of orchestration platform. Now, the most popular orchestration platform for containers is Kubernetes. Now, if we take a high-level overview of Kubernetes, what we can see is that there are two types of nodes within a Kubernetes system. You have a control plane node and you have a worker node. Now, the worker node is the actual element or the actual server in some cases that runs the container, that runs the application. The Kubernetes control plane nodes make sure that those containers are started on those worker nodes and restarted if something happens. And all the orchestration happens inside the Kubernetes control plane. Now, this is necessary to run this containerized application, but are you done at this point in time? Well, according to a lot of the media and a lot of the cloud native experts in the industry, this is the future. And we don't really agree with that, because yeah, you can create a new online banking app, but how do you make sure that the right people connect to that app? And how do you ensure that that containerized application can provide the services that the bank offers? So in order to do so, you needed to connect it to those services. Well, and this is the case. Typically, those services, they run in traditional formats, in virtual machines, in the industry standard. And so what you see is that a VM might run the customer service And the database provides the data that allows you to understand which bank account belongs to which customer. And so that containerized application need to connect to those applications and to those databases. So what we see is an environment that now has two personas, a developer persona and an IT ops persona, figuring things out from their side. So the developer thinks about, okay, so how do I deploy this app? Deploying this app in Kubernetes is easy for them, but how do you connect to those traditional applications and databases? And how do I make sure that if something happens along within the stack, my online bank app still works? How do I get access, and what tools do I use in order to understand the full picture? Now, from the IT ops perspective, now they see this new environment coming in, the Kubernetes environment. So how do you ensure the availability of this app? Because now they need to figure out how to provide availability for that Kubernetes environment, and maybe even for that containerized application. How do you ensure security? How do you make sure that there is the security baseline attached to that Kubernetes environment? How do you deliver quality of service? How do you make sure that that Kubernetes environment gets the right physical resources? And how do you control the cost of the infrastructure? Now you have a developer just deploying things. Maybe it will cost an enormous amount of money. So these questions are very interesting. And for us, being basically the provider for the platform for most enterprise applications, this makes sense to focus on. So what we've done is, when Kubernetes was released, we already started to work on some of the elements. So in 2017, just 2 years after Kubernetes was released, we released Project Hatchway, which provides persistent storage volume to containerized workloads. A year later, we released NSXT, providing per container networking services and load balancing services, all to focus on containerized workloads. In 2018, we also acquired Haptio, and the reason why we did that is 2 of the 3 founders that worked at Google founding Kubernetes, they spun up their own company called Haptio. So when we bought it, we got an enormous amount of mind share and an enormous amount of knowledge about the Kubernetes platform in-house. On top of that, they had a really interesting upstream compliant Kubernetes version, which we could use in our own environment. And so in 2019, we announced vSphere with Kubernetes at VMworld 2019. And along the way, that product name has changed. And this is something that Cormac, who will follow me in my presentation, will talk about that more extensively. And so vSphere with Kubernetes, or what is now called vSphere with Tanzu, allows you to run and deploy Tanzu Kubernetes grid services environments and run native vSphere pods. So let's take a closer look at that. So we have vSphere 7 with Tanzu, the new name of vSphere 7 with Kubernetes, and Tanzu Kubernetes grid services. Now that TKGS is an upstream compatible or compliant Kubernetes distribution, and we run it inside virtual machines. vSphere 7 has now got this service that allows you to use the original tools for the developers to deploy these TKGS clusters on your vSphere platform with just a few commands. Another thing that we have is the native pod. Now, the majority of this roadshow is focusing on TKGS, but let's stop and look at the native pod for just a moment. So what vSphere 7 with Tanzu also offers is the ability to run a container as a native construct within the vSphere platform, within the hypervisor. Now, if you look at a container itself, it's just actually a collection of processes, typically Linux processes. The majority of containers in this world run on Linux platforms. Yeah, there is a possibility to run a container on a Microsoft platform, but the majority of people running containers do so in Linux machines. So in order to run a container, we need to provide a Linux operating system, as it is a Linux OS, a Linux process. Now, ESXi is not a Linux operating system. So we need to provide a way to inject a OS in the environment. And what better method than to use a virtual machine? So we created this lightweight virtual machine with our own Linux OS, Photon OS, who only uses para-virtualized devices. So we keep the driver list very tiny and the footprint in total of that virtual machine very tiny. And because we're using a particular number of para-virtualized devices and a select few devices, we can make it extremely quick. So we have this lightweight virtual machine who is just there to run a container. The only thing what we need to inject is a container runtime and the ability to interact with that container. So that is what CRX is all about. And that's it. And at that moment, you can actually run a container in its own tiny pod VM or vSphere pod. And now within the vCenter UI, you can actually see those elements. So that's what we mean by a native construct. We can run it. We can provide particular commands to it at the hypervisor layer, but also at the vCenter layer. Now, like I said, the majority of this roadshow talks about TKGS, because in order to run vSphere pods, you need to have a NSX deployment. And so we're focusing on the vSphere networking side of this story in this roadshow. Now that combination of the ability to run vSphere and run virtual machines, but also now deploy Kubernetes clusters with just the native tools, that creates this self-service platform for developers. No longer is it necessary for a developer to contact the IT ops team to deploy an environment. They can do that with their own tools. Now, we still want the IT ops team to control the environment, to make sure it's secure, it's available, performing well. So we created a tool set that allows the IT ops team to manage the environment and to manage the situation where developers can deploy the environment without becoming noisy neighbors or over-consuming the entire environment. So how do you do that? And that's the next phase of this presentation. So one of the things that you need to do when you want to run this environment is to enable workload management. Now, interestingly enough, within the UI, there's no notion of the word Tanzu. The actual functionality within the vCenter is called workload management. So go to menu, there you can see workload management. And when you enable it, you have to go through a number of steps. This is something that Cormac will describe in his session up next. Now, you can use NSXT or you can use vCenter server network. That's basically the distributed switch. And then you need to have a virtualized load balancer. You can use HAProxy or you can use the new advanced NSX load balancer. And once you go through all these steps, and I used HAProxy in my environment, you see the situation which is on the right side of your screen. You see the host and cluster view. In this case, I have this cluster called NX with 3 hosts. And underneath that host, underneath those hosts, there is this new resource pool called Namespaces. And in that Namespaces are 3 virtual machines called Supervisor Control Plane VMs. And these virtual machines, they make up the control plane of the Kubernetes cluster that is integrated with the vSphere cluster. And the combination of Kubernetes and vSphere is something what we like to call the supervisor cluster. You can also see that I have this virtual machine being deployed called HAProxy. Now, at this point in time, we have a Kubernetes control plane. And that means that a developer can now use their own tools, their own command line tools, to interact with the Kubernetes API endpoint of the supervisor cluster. And now they can start to deploy their own environment. Now, this might be a little bit dangerous to allow developers that don't have really good awareness about running a infrastructure platform just to hand over the keys to them and say, go knock yourself out. So what we want to do is we want to guide them. We want to create some sort of guardrail for those developers. And that's the construct called a namespace. This is what we introduce in vSphere, the workload management namespace. And that allows the IT ops team to apply some of the quality of services to that particular environment. And that allows the developer to deploy their workload in that namespace and not being able to overconsume the environment. So let's take a closer look how you do that. So once you configured workload management, the next step is to create that namespace. So you go to workload management in the menu, and there's this button called create namespace. And there's just a few simple steps. You select the cluster, you give it a name, you give the namespace a particular name, you select the network for that particular workload, and then you can leave a description. And then you click on create. That's it. So at that point in time, what you will see is that there is now a new icon underneath namespaces, which is called the online bank app. I created a namespace called online bank app. And if you click on that icon, you will see a summary page, what you see on the right. And you can see the status, the permissions, the storage, capacity usage, and how many Tanzu Kubernetes grid services or clusters are actually running in this namespace. Now, this is just configured, so we need to apply some additional steps. One of the steps is add permissions. The other step is to provide a particular storage policy to that namespace. So you click on that, you can add the permissions, you select a group out of your vSphere, your vCenter environment. You can say can view or can edit as a role. You click on OK, that's the permissions done. Now the next step is storage policies. Select the storage policy that you think is proper for that particular workload that is being deployed. So maybe there's this test environment, so RAID 5 will suffice, but maybe a production environment needs to have a RAID 6 or maybe needs to have a mirrored environment. So apply the particular storage policies to that namespace so the developer can specify those storage policies for their workload. So the next step is optional, and that is to limit the amount of physical resources that environment can consume. So you set a limit on CPU and on memory, and in this case, I set a limit to 50 gigahertz and 64 gigabyte. Now, the developer can deploy many machines as long as it's not using a reservation, and so all the physical resources are consumed by using shares. But the moment there is a need for more than 50 gigahertz physical, the limit will be applied, and that's the total amount of physical resources that is being allocated to those machines in that particular namespace. So that allows you to safely provide access to the developers without the chance that they can completely reserve the entire environment for their test environment, for example, right? And so once you click on OK, in the summary page, you can actually see the limits in just one glance. You don't have to click on anything, that it's just right there. So that is the beauty of the namespace, that it allows you to see the quality of service applied to this particular application in just one glance. So this allows you to change your behavior, the way you manage your applications in your data center. Now you can provide those namespaces as a reference to your applications, and you just have to select the particular namespace to look over at the entire quality of service for your application. Now, once everything is set, the developer can deploy their own TKGS cluster by using the API endpoint of the supervisor cluster, specify the namespace, and at that point, once the supervisor cluster, the control plane nodes are done, that those virtual machines are spun up in that particular namespace. And now the developer can connect to that particular Kubernetes API endpoint of that particular Kubernetes cluster and deploy their application or do the testing that they want to do. So there's no interaction with the IT ops team. They can use their own tools, they can use their own systems to deploy their own environment. So it's somewhat, or it's actually better, I believe, than going to a global cloud provider such as an Amazon or an Azure, and you go through all the steps on the web page in order to figure out what you want. In this particular scenario, they can just use their command line interface, connect to a on-prem cluster, and spin up their Kubernetes cluster with just using their own set of tools. So I think that's a very interesting proposition for your developers. Now, the next thing, of course, is once you provide the access to developers to your environment, you want to create this consumption strategy. And so what you want to do is you want to make sure that what they deploy, what the developer deploy in their environment is being appropriate for your environment. So what they typically do is they use their own YAML file. This is something that Cormac will discuss in more detail than I will do. And it will specify the size of that TKGS cluster. So in that deployment YAML file, there are many different specifications, but the one that I want to focus on is the virtual machine class. And in this case, highlighted in red, the developer deploys a 3-node Kubernetes cluster, 1 node to act as a control plane, 2 nodes that act as a worker. And what the developer has done is he or she defined the guaranteed medium as a class, as a size for the control plane, and a guaranteed large for the worker node. Now, in total, by default, there are 16 classes. So let's go over that a little bit more so you can understand what this actually means. And so there are 2 types of virtual machine classes by default. There's the best effort and there's the guaranteed. A best effort does not have any reservation. A guaranteed class has a reservation for CPU and memory that is equal to the configuration size. So if we take a look at a large class, so let's use a guaranteed large class, what we can see is that that virtual machine will get 4 vCPUs and 16 gigs of memory. And now it's protected by that with a reservation, a CPU reservation and a memory reservation. Now what you can see is that there are different sizes ranging from 2 CPUs up to 32 CPUs, from 2 gigabytes of memory to 128 gigabytes of memory. So maybe that doesn't fit your environment and maybe you want something else. So in the latest update, we released the Tanzu VM service. And one of the things that you can do with the Tanzu VM service is you can create custom virtual machine classes. So one of the things that you might want to do is possibly create a burstable class. And a burstable class is something that is present in Kubernetes environments, and that is a particular setting of a reservation, but not the entire range of the configuration of that machine. So in this scenario, I created a burstable small class providing 2 vCPUs and providing 60% of resource reservation. So up to 60% is protected by physical resources, but up from 60 to 100, this is something that needs to be allocated by the share value. Same goes for memory, 4 gigs, 60% is protected by a reservation. And that allows you to create multiple classes. And now the next thing you can do is to assign particular number or particular virtual machine classes to a particular namespace. So if you know that a particular team is doing some testing and is just trying to figure out what to do with this containerized application, you might also just want to provide virtual machine classes that are of best effort or burstable, maybe not guaranteed, maybe only provide a particular size because maybe they don't need to have this monster VM to deploy their test environment in. So in the UI, you as the admin or the IT ops person can see what you're going to deploy or make available for that namespace. The developer can use his or her own tool and ask the system which virtual machine classes are available for their namespace. Now, this is very interesting, and I believe that this is something that you can use to provide your insight and your knowledge about the infrastructure. You know exactly what type of host type you're using from an ESX perspective, especially from a CPU and memory configuration perspective. So what you can do is you can say, okay, I've got these ESXi host systems with a particular NUMA configuration. I know that within each NUMA node, there are 10 cores and there are 128 gigs. So what I'm going to do is I'm going to create this virtual machine class of different sizes. And if the developer selects those sizes, they're getting a uniform memory access, meaning that they're getting consistent performance because they're staying within a single NUMA node. So you're creating those custom virtual machine classes, providing it with a useful name, understanding that, hey, if I want to have consistent performance, if I want to have low latency, high bandwidth performance, I, as a developer, need to select a particular UMA virtual machine class. Now I've got the choice of 2, 4, 6, or 8 gigabytes. And I know that the amount of memory assigned to my Kubernetes worker node, it can fit inside a NUMA node as well, meaning that I get local performance, low latency, high bandwidth. Now for larger environments, you might want to create a NUMA type virtual machine class, indicating that these classes will span multiple NUMA nodes. So there might be some inconsistent performance, but if you apply NUMA optimizations at the application layer, that's not the case. And now you can create larger environments. What you can also do is avoid that the developer will spawn a high density wide VM. And that means that a high density VM needs to use hyperthreads because it's using so many vCPUs that the CPU scheduler cannot schedule them all on cores alone, on full cores alone. It needs to use hyperthreads. That's a noisy neighbor. And because it's so big and because it uses hyperthreads, it's a noisy neighbor that isn't happy by itself because it doesn't get the resources that is required. And so by creating this custom class, you can avoid a developer making the wrong choice and getting a better informed decision without you hand-holding them and creating those sizes because you built this for the environment. Now, another thing that you can discuss with your developers if you have a conversation with them is how they can size their control plane nodes, because the size is dependent on the operations that are expected. If you have a lot of operations, meaning that there's a lot of churn containers being spun up, being destroyed over and over again, that's where you want to apply or provide more resources. But if this environment is just deploying a particular container for every once a week or whatever, for a long period of time, you don't need to have that size. Same goes for reservations or not. If you're having a production, you want to have consistent performance. You want to have a protected environment that will be there even if a ESXi host fails. So for that particular use case, you want to use a guaranteed virtual machine class for interactive testing by developers, maybe a burstable or a best effort class is better. And one of the other things is that Kubernetes by itself needs to have resiliency, needs to get a high available environment. We do that for the supervisor cluster. We deploy it with 3 control plane nodes, but maybe your developer want to provide some availability for their control plane nodes as well. Now there are some ways to do that, but most of the time, actually, you can trust on vSphere HA. Now, let's dig into that a little bit more deeper. So if you look at Kubernetes, you have the worker nodes, and the worker nodes run those pods. Now you use a command line interface or maybe a CI/CD pipeline in order to run or deploy that pod on that worker node. But in order to do so, you need to connect to the control plane node, because that's the actual element that makes sure that pod, that collection of containers, will appear on a worker node. So a control plane node consists of many different things. And one of these things is the API server. The developer connects to the API server, issues a particular command, and that command is being stored in the etcd database. etcd is a key value store, and it's a quorum-based database. So that everything is stored in that etcd database. And once it's stored, that generates an event. And all the managers and all the schedulers inside Kubernetes watch those events. And if an event is triggered, that triggers a particular scheduler or a particular manager, and they do what's necessary in order to make sure that that command is how can I say this, is being executed properly. Now, it means that the source of truth, everything that happens in the Kubernetes environment, is present in the etcd database. So you want to make sure that that's highly available. And that's the reason why you see 3 nodes, because it's quorum-based. So you need to have the majority available. So if you want to tolerate a failure of 1 control plane node, you need to deploy 3 control plane nodes, because 2 needs to survive. 2 etcd databases need to survive. But if you want to have more toleration of control plane node failure, you need to deploy either 5 or 7. Now that's a lot of worker nodes just to provide availability for your control plane nodes. We're not talking about your application. We're just talking about ways to interact with your Kubernetes environment. And so maybe vSphere can help you. If we look at the high availability environment, my headset just disappeared. Can you still hear me?
Yeah, we can hear you.
Oh, nice. I'm getting bleeps in my ear about my headset. So let me know if I'm talking and you don't hear anything anymore. So the Kubernetes failure response timeline is actually roughly about 350 seconds long. In order, when something fails, in order to do so for the Kubernetes environment, it takes up to 350 seconds to do so. Now, compare that to vSphere HA. Typically, within the 30 seconds, we understand that something is wrong and we take action. So maybe within 60 seconds, your Kubernetes control plane node is up and running on another ESXi host node. So if you explain that to your developers, it makes sense that, hey, maybe a combination of Kubernetes, deploying 3 control plane nodes, and then trusting on vSphere HA to take care if a ESX host fails, that might be the best solution instead of overly consuming the entire environment by just creating resiliency from a Kubernetes level alone. And so from a worker node perspective, pretty much the same thing. How many resources does an application need? That decides or that decides the size of the worker node. The availability of the containerized workload depends, or basically determines the number of worker nodes. If you have an application with 3 replicas, you might want to have 3 worker nodes. It's a Kubernetes worker node is a soft fault domain, meaning that if you deploy 3 replicas on 3 nodes, Kubernetes will deploy a replica, a container on each node separately. But if you're deploying 6 replicas of that application, but you still have 3 worker nodes, Kubernetes ends up with 3 applications or 3 replicas that needs to deploy somewhere. So what they do is they just start and run another replica on the host that already contains a replica. So you will see 2 replicas per host. So that's the reason why we call it a soft fault domain. Now, for worker nodes, that's where the application runs. So it's very important. If you're running a production environment, you might want to use a guaranteed or maybe a burstable class. For test environment, you can use a best effort or a burstable class. I don't think a guaranteed is necessary for that environment, but that's up to you and that's up to your developers, of course. And the last thing that I want to touch upon is, if you look in the future and you committed to containerized applications and you're running your vSphere platform to host your Kubernetes environment, you want to think about how dynamic is my environment. You might want to compare it to a VDI environment. In some cases, a VDI environment is spun up, completely separated from a vCenter perspective, from a control plane perspective, because there's so many things going on. Same thing that can happen in your environment, where a lot of developers spinning up new Kubernetes clusters and breaking them down and spinning them up. There's a number of operations what you can do within a vCenter, and maybe you don't want to be, you don't want to get interference by that. So one of the things is think about how dynamic your environment will be, and plan accordingly with vCenters and with sizing of your vCenter and all of that. Now, from a HA perspective, and that's something that is one of the most popular environments in the most popular topics in virtualized land and also in containerized land. So that's a topic that you want to start discussing with your developers. Think about how vSphere HA can help your containerized applications by providing resiliency to the Kubernetes layers. And with that, I would like to thank you. This was my part, the first part. Cormac will follow up, and after Cormac, Duncan will finish the roadshow with his presentation. Now, I saw somebody, I think I saw Ahmed reaching his hand. Are there any other questions, Cormac?
Sorry, Frank. Yeah, I think we're covered.
Okay.
There were lots of questions.
Oh, nice.
And yeah, so it's probably easier if people just type them into the chat. Frank still has a few minutes, and we can cover them live. And then you can continue to ask the questions, and while I'm presenting, and Frank and Duncan will pop in there and answer your questions.
Nice. That's a lot
just
of
looking
questions.
Yeah, I think most of them are covered, Frank, but I'm just looking at the time. I probably should get going on my part, and perhaps you could just add any context you have.
I will.
The ones that are there. Perfect.
Thank you.
Okay. So let me share my screen. Awesome. So hopefully you can all see that. Hello, everybody. My name is Cormac Hogan. I work with Frank and Duncan in Cloud Platform Business Unit, and I'm going to follow on from Frank. Frank gave us a really good deep dive into vSphere with Tanzu, Supervisor Cluster, Namespaces, all of that kind of stuff. I'm going to take it sort of at a practical level, and so we'll go through what's involved in setting it up, how to configure it, how to deploy it, and I have a few demonstrations of that as well throughout the presentation. Okay, so this is what I plan to talk to you about. You may have come across the term Tanzu used an awful lot recently from VMware. We're talking about one particular Tanzu edition in this presentation, and I'm going to sort of set the expectation here about what Tanzu we're talking about, because there's quite a few of them. Then we're going to talk about probably the evolution of vSphere with Tanzu. It came out last year, but it was only available with VCF, but there is a lot of requirements and restrictions that have been lifted since then. So I'll show you how to get started with that. There's a few different ways that you could deploy vSphere with Tanzu. I'm going to take one in particular, which uses a HAProxy load balancer. And this is the one that probably most often be used in a proof of concept, and see, it's certainly even in a a lab environment. It's the easiest way to get started with it. So I'm going to go through the deployment steps of the HAProxy load balancer, which is a requirement then for vSphere with Tanzu. What you'll notice in the vSphere UI is that we don't talk about vSphere with Tanzu, we talk about workload management. And so I'm going to go through the enablement of workload management and show you how this supervisor cluster gets deployed. And then last but not least, I'll show you probably the main use case of why we have vSphere with Tanzu. And this is the ability to deploy Tanzu Kubernetes Grid guest or workload clusters. So these are VMware engineered upstream Kubernetes that your developers would work on. And last but not least, I'm going to introduce you to a feature that requires vSAN, but is integrated with vSphere with Tanzu, called the Data Persistence Platform. And that's a nice segue then into Duncan taking over, where he's going to talk about all the really cool stuff that came out with the latest versions of vSAN as well. So hopefully that's interesting for you. So as I said, we have a bunch of different Tanzus. And there's one in particular that we use with vSphere with Tanzu. So the first one I want to highlight, this is not what I'm going to be talking about in this presentation, but it's the TKG, the Tanzu Integrator, Tanzu Kubernetes Grid Integrated Edition. This is the one that was formerly Enterprise PKS. It's kind of a joint initiative between Pivotal and VMware. That's our first distribution, our first Kubernetes distribution, but it's been rebranded now and it's called TKGI. So I won't be talking about that one. And there is another one, a TKG, we sometimes refer to it as TKGM, short for multi-cloud. And this is a version of Tanzu that can be deployed on lots of different clouds, both public and private. You can indeed deploy it on top of vSphere, but you could deploy it on other clouds as well. This one does not require vSphere with Tanzu. So this is the one I won't be talking about either. The last one is the TKG Kubernetes clusters that are deployed through a TKG service. This is the one that's embedded into vSphere with Tanzu. So this is the one we're going to be covering. When I talk about Tanzu in this presentation, it is the TKG clusters that are deployed through the TKG service that is embedded in vSphere with Tanzu. So just a little bit of clarification around that, because I know it can be very confusing with all the different Tanzu editions that we have. Okay, so I know Frank has spent a little bit of time talking to you about how all this is built up, but I just want to kind of take it back as well and just run through it and how we go about, or what are the major components that are set up when we deploy vSphere with Tanzu. So you have your vSphere environment. Okay, I'm going to start with that, and we have vSAN here in the mix as well. So when I enable workload management, which is basically turning on vSphere with Tanzu, what happens is 3 virtual machines get rolled out, which form the supervisor cluster in vSphere with Tanzu. This is our supervisor control plane, and it is, for all intents and purposes, a Kubernetes distribution. It has exactly the same purpose as a control plane in Kubernetes, except this one has, let's say, an understanding of the vSphere infrastructure. So when this has been deployed, you're now able to go ahead and create what are called namespaces. Again, Frank has touched on this, but we can think of this as just a way of allocating resources to developers, vSphere resources to developers. And once you have a namespace, then you can do all sorts of good stuff in here, like set permissions, allocate storage policies, set limits, and so on. All of the stuff that Frank has been talking about. So once we have the namespace, what can we deploy inside in these namespaces? Well, we've lots of options. We have this thing called a pod VM. So Frank talked about this. It is, if you're familiar with a vSphere product called vSphere Integrated Containers, it is very similar to this. It essentially gives you the agility of working with containers, but you get the security and isolation of a virtual machine. So it's essentially a container running in a VM. We also, since 7.0 Update 2, have the ability to provision virtual machines inside namespaces as well. And all of these are created just through very simple manifest files. And we'll look at some of those later on. But the manifest files, Frank showed us some examples. These are just YAML files. If you're familiar with Kubernetes, everything is done through YAML files. And these manifests or YAML files can be used to deploy these different types of objects. The most popular object we get created is another cluster, and this is an upstream TKG cluster. Again, you just put into the manifest file, or your developer puts into the manifest file, the version of Kubernetes, the number of control plane nodes, the number of worker nodes, all of that good stuff gets placed into the manifest file. You send it up to the supervisor cluster, and it builds out this Kubernetes cluster for you. And so this is typically what we would see vSphere with Tanzu used for, just deploying out these upstream VMware engineered, VMware supported Kubernetes clusters that your developers can use for deploying applications. And of course, depending on the amount of resources you have, you could have a combination of all of these in the same namespace or multiple versions of these in the same namespace and so on. But that is it in a nutshell. That is what vSphere with Tanzu is allowing us to do. So let's go ahead and see a little bit more about how this all came about. Now, I said about over a year ago now at this stage, we had our first edition of vSphere with Tanzu, and it was only available with VCF. So you did have to have VCF in order to get started with this. And there were a number of reasons for this. If you're not familiar with VCF, a VMware Cloud Foundation, this is our easy button for standing up a software-defined data center. So it brings in all the virtualized compute, the virtualized networking through NSXT, virtualized storage through vSAN, all the management and monitoring through the vRealize products. It's all stood up together in a software-defined data center. So because Kubernetes has a requirement on all of these things, especially the networking, this is why we went with a VCF deployment for the support of vSphere with Tanzu initially. Now, what this provides then is a whole bunch of services. Obviously, storage services, because your applications that you deploy in containers in Kubernetes needs to have some persistent storage and volumes. So we have that available. Networking, obviously, there needs to be pod-to-pod secure communication. So NSXT does that. Also, overlaying of networks to provide that secure communication. So this is why NSXT is in the mix here as well. Pod VMs, we talked about that. Frank talked about it as well. This is the container in a VM, agility of containers, security and isolation of VMs. So that service was another one that is included. And the VM service as well, the ability to create VMs, that included just recently with 7.0 Update 2a. And finally, the registry service. So the registry service is based on a VMware product called Project Harbor. This is an on-prem secure image registry, where you can save all of your images, your container images. Your developers then have a secure on-prem environment for these images. They don't need to go out to some third party on the internet to pull down images and so on to use within containers. So these were the different services, but again, and I mentioned this before, the real use case was the ability to create these Tanzu Kubernetes clusters, VMware engineered, VMware supported, very much upstream Kubernetes. And so developers can roll these out within their own namespaces as well. And again, this is the TKG created from a TKG service and not any of the other Tanzus that we mentioned earlier. And so your developer can access all of these that, it's just through kubectl, if you're familiar with that, to access the Kubernetes API. And so, it's an environment that if they've already used Kubernetes, they will be very familiar with, very much the same look and feel and so on. So this was with VCF 4.0, but what we heard from customers, not everybody uses VCF and not everybody has NSXT. So could we make an edition that was accessible to even more customers than just those customers who had VCF? And so this is the sort of, I don't know what the name to put on it, maybe the proliferation edition, but essentially what it is as of 7.0 update 1 and again 7.0 update 2, we relaxed the requirements. So you no longer need VCF, you no longer need NSXT, but that actually changes some of the features that are available. If you notice now in the infrastructure services, we no longer have the pod VMs. This is because we required NSXT to do network overlays. Without NSXT and just using vSphere storage, there is nothing to provide those overlays, so we can't run the pod VM service. And because the Harbor image registry service was sitting on top of pod VMs, now that pod VMs have gone away, we don't have the image registry service available either. But once again, the main use case really is the Tanzu Kubernetes grid service and the ability to create upstream Kubernetes clusters within a namespace. So that is still available there, as are the ability to do create persistent volumes. And the network service now refers to the load balancing service that I'm going to talk to you in just a moment. And what we've done is, because there's no NSXT, we've made it possible to deploy just the load balancing service outside of NSXT. So this is just a recap of the different releases and additions. Really, the main thing to highlight here is just the different load balancers. So when we came out with VCF 7.0 initially, it was NSXT only. 7.0 update 1, we introduced the HAProxy appliance. And with 7.0 update 2, we now have the NSX advanced load balancer. And this is based off the AVI Vantage. VMware acquired AVI. I'm not sure exactly when, maybe about a year ago, maybe a little bit longer than that. But what we've done is we've taken the AVI Vantage product and we've now created an NSX advanced load balancer that can provide this load balancing service for us once again. So I'm not going to go through all the requirements. There was a question came up earlier about how many nodes would I need in order to deploy vSphere with Tanzu. You need a minimum of 3 nodes. Because the control plane is made up of 3 VMs, that supervisor cluster has 3 VMs, and they need to be placed on different ESXi hosts for availability purposes. And so that's why we need the 3 nodes there. And there's a few other things, but I'm not going to spend too much time going into those. So I'm going to now talk about the HAProxy load balancer. This is just one of the load balancers we have available. You also can do NSXT or the NSX advanced load balancer, but I focused on the HAProxy because this is the one I think is probably the simplest one to get started with, and possibly the one for if you want to do it in a lab and just try it out for yourself, the one you're probably going to use. So there are 2 ways of deploying vSphere with Tanzu. The first of these is with this 2-network approach, 2-NIC approach. We have your management network where your ESXi hosts are and your virtual center resides. And then you have a workload plus front-end load balancer network. So this is the same network, but maybe segmented into 2 different ranges or CIDRs. The other networking option is this one, where you separate out the workload network and the front-end load balancer network. So here, there is still a route between the 2, but the workload network is where the Kubernetes nodes get deployed on, or the Kubernetes virtual machines, if we want to look at it that way. And then access to those Kubernetes clusters is through the front-end load balancer network. So that's probably the easiest way to think about this, is that the workload network, this is where we deploy Kubernetes. The front-end load balancer network is how the developer would interface with the Kubernetes clusters or access to Kubernetes clusters. So if we're going to deploy this HAProxy load balancer, in this case, we'll deploy it with the 3-NIC configuration. Now, it just comes as an OVA. You deploy out the OVA to decide whether it's a 2-NIC or 3-NIC configuration, and then you just fill in a bunch of networking type information. It's all very well documented at this point. I suppose the one thing to note here is maybe the port that we'll come and visit later on, and how a lot of these entries are CIDR format. So the whole point of this thing is that when a Kubernetes application or a Kubernetes cluster comes online, it looks for a load balancer IP address, or it looks for a front-end IP address. And the purpose of this appliance is to provide those load balancer IP addresses for either the Kubernetes clusters or the applications that require a load balancer IP address. So a bunch of things to bear in mind when you're coming to deploy vSphere with Tanzu. Namely, there's a lot of things that you need to take into account for the HAProxy, such as address ranges, but also when you come to enable vSphere with Tanzu. So there's three networks that you need to bear in mind. There is this front-end load balancer network that requires a range. And again, this is where Kubernetes will request an IP address, or the application will request an IP address, and it's the purpose of the HAProxy to provide that. There's the management network that is, we need a range of 5 IP addresses there, and those are for the supervisor nodes or the supervisor VMs that we'll see get deployed. So that is the vSphere with Tanzu control plane, 5 IP addresses on the management network. Last but not least, there is the workload network. So this is the third network that we were talking about, and you need a range of IP addresses there as well, because all of the TKG guest workload clusters, they all populate onto that workload network. So 3 network ranges to keep in mind. Front-end load balancer needs a range, management network needs a range, but only a range of 5, and the workload network, which is used by the supervisor nodes and also the TKG nodes, needs a range of IP addresses available as well. So there's quite a few here. There's a few really useful tools that I use all the time when I'm deploying out vSphere with Tanzu. The first of these is the IP address conversion guide, just to make sure that the range and the CIDR match up, because you're asked to provide the range in some places and you're asked to provide the CIDR, the matching CIDR in other places. Some tool that does the CIDR to IP range conversion is very useful to have. I can never work them out in my head, so this is why I rely on these tools. The second one is an IP address scanner. And the reason I use this is that once the HAProxy load balancer has been deployed, the range of IP addresses that it is providing as load balancer IP addresses become pingable. Even though they haven't been allocated to anything, they become pingable. So this is just a really good way of verifying that the HAProxy has actually come online for you. So those 2 tools I use all the time. So assuming that everything has gone well in our 3-NIC deployment, I will have a HAProxy that looks something like this. It'll be configured on the management network. It'll also be on the workload network. And last but not least, it'll be on the front-end network. And as I said, put the IP scanner onto that front-end network, let it run through, and the whole range of IP addresses that you've allocated to the HAProxy should become pingable. There's another thing that you can check, and this is that the HAProxy, you can connect to a URL of the HAProxy using that port number that you configured there previously. Provide the credentials, the same credentials you provided when you deployed the OVA, and you should be able to get back some sort of metadata as shown here. And this just verifies for you that the HAProxy is working as expected. And the reason why I'm spending so much time in getting the HAProxy working is that there's no point in proceeding with enabling the vSphere with Tanzu component until the HAProxy load balancer IP addresses are accessible. So hopefully that makes sense. Great, so let's assume our HAProxy is good to go. We're now going to go ahead with the workload management. And this is essentially enabling vSphere with Tanzu to create the supervisor cluster. So again, no NSXT in this environment. We're going to go with vSphere networking, and we're going to use the HAProxy for our load balancing service. So what should happen then is it rolls out the 3 supervisor VMs. Those VMs are plumbed up both on the management network, because we gave that range of 5 IP addresses, but they also get plumbed up onto the workload network. So they become multi-homed. Okay, so there are 2 network interfaces for each of the supervisor VMs. When they all start to communicate and that they are all happy that everything is online, they reach out to the load balancer, or HAProxy in this case, asks it for a load balancer IP, and then changes the control plane node IP address to a load balancer IP, which you as the vSphere administrator or your developer can now use to access that cluster. Okay, so that's the whole purpose of that. So Assuming now the HAProxy is working, and assuming that the supervisor enabled successfully when we turned on vSphere with Tanzu, we should see something like this: the 3 supervisor nodes coming up onto the management network and also coming up onto the workload network. And when they all reach steady state, they will reach out to the HAProxy to provide it with a front-end load balancer IP address that your developer can then use to access the cluster. So hopefully that's making sense. And what we can do now is, I think I have a short demo, and we can go through and see how this works in earnest. So this is a vSphere 7 environment. You can see workload management is a new feature there. We are using vSphere distributed switches, not NSXT. I am going to choose a cluster on which to enable vSphere with Tanzu. I'm now going to select the size of these nodes for the supervisor VMs. And in this case, I'll just go with small. I'm going to select the storage for these VMs, and I'm just going to pick a policy, which was just a vSAN default policy. And now I start filling in my first networking information, which is the load balancer information. Because I'm using a HAProxy, I'm just telling vSphere with Tanzu all about the HAProxy and how to access it and what range of IP addresses the HAProxy is going to provide for us. So all of that load balancer information is added there. The next step is the management network. This is where I allocate the 5 IP addresses that are used by the supervisor nodes, and I give it the starting IP address. So it starts at 191, and it'll take 4 more IP addresses after that. The rest of this networking information is quite straightforward, just DNS, NTP, gateway, and all of that good stuff. So that's 2 of the networks now complete. The third network is the workload network, and this is the one where all of the nodes, the Kubernetes nodes, are plumbed up onto. So I'm just going to add a single workload network here. You can add multiple ones. You just give it a name, you select which port group that this workload network is going to be, give it a gateway, what's the subnet mask, and then the range once more of the IP addresses for the workload network. And each of the Tanzu Kubernetes grid guest clusters or workload clusters that I deploy here are going to consume IP addresses from that range. Last but not least, I need images for my guest clusters, and the images are available in a content library which has a subscription on it that I select as the very last step. So I leave that deploy. It usually takes about 10 minutes, but I can speed things up here, fortunately. And now we can have a look at our host and clusters view, and we should begin to see the supervisor control plane VMs appear. And there they are, the 3 of them there. They should get the two IP addresses. This one actually gets an additional one. This is the etcd key value store, gets its own IP address there. And this one, has 2 IP addresses, one on the management and one on the workload. This one we're still waiting for, but again, we can speed it up. And within, as I said, about 10 minutes, I think it normally took with the HAProxy, we should see the config status change to running. And now we get a control plane IP address that is off the load balancer range. I can then go ahead and create namespaces. Frank has talked to us a lot about this already, but this is basically, for want of a better description, just some resources allocated on a per developer basis. And we can see the network there that's used is the workload network that I created. There are links here for developers to download tools to allow them to interact with their namespace. They're available there to download for different operating systems. Permissions, don't worry about that too much. Storage, this is where we allocate storage policies to a namespace, and they become storage classes actually in Kubernetes when the developer is working on that. Limits, Frank has talked about those as well. I'm not going to set any here. And the Tanzu Kubernetes section will fill in as I create guest clusters. But that is essentially it. We now have vSphere with Tanzu enabled on our vSphere cluster, and we're good to go with creating some guest clusters. So with that in mind, I'm going to move on, and we'll spend a little bit of time talking a bit more about the most common use case for vSphere with Tanzu and namespaces, which is the creation of the guest clusters probably don't use guest clusters quite so much. Maybe workload clusters is a better description. So I think we should be comfortable now with what a namespace is. Frank has talked about this a lot. I've talked to you about it quite a bit as well. But it's essentially allocating resources to developers from vSphere. So we talked about the tools. One of the tools that a developer might download is this kubectl vSphere, which allows them to interact with their namespace and do all sorts of good stuff within their namespace. This is typically logging into the namespace. I am using an administrator here. You probably won't do that. You would set up individual users, but just for the purposes of demonstration, I'm using administrator. Provide the password, and now you're logged into that particular namespace or your context that you have access to. So we know that Cormac NS is the namespace I created previously, so I have access to that. Now, once I'm in here, like I said, there is a bunch of things that you could do, like creating virtual machines, creating pod VMs, but really the main use case is deploying these workload clusters. And here is an example of the YAML, yet another markup language manifest file, which has all the information about creating this guest cluster. So you can see the kind here, Tanzu Kubernetes cluster. We give it a name in the metadata section. And in topology, what we're saying is that this cluster has a single control plane VM, which is of class guaranteed small, and it's going to use this storage class, which is the vSAN default policy, and we're going to have 2 worker nodes. So this is where we define the control plane, the number of worker nodes. This is where we say what node resources, what size they are. And then we have lots of different distributions of TKG as well. And in this particular case, it's Kubernetes version 1.17.8 is what we're going to deploy. And so it's as simple as that for a developer to create a guest cluster, a workload cluster, in order to have that native Kubernetes experience within vSphere with Tanzu. Once that is rolled out, what we'll get is 3 new VMs. 1 is the controller, 2 are the worker nodes. They will be plumbed up onto the workload network. They will get these IP addresses allocated by vSphere with Tanzu. And the control plane, once again, will be wrapped around in a load balancer front-end IP address. And this is how the developer will interact with that cluster. I have so just by way of interacting with that cluster, then the login slightly changes. We're no longer logging into the supervisor cluster. We're now logging into the workload cluster. There's a few additional options used here to do that. And now we're dropped into that particular context. And anything that the developer does here is against the native upstream TKG Kubernetes and not against the namespace on the supervisor cluster. So there's one short demo left to show you, and this is just taking our namespace and creating a guest cluster. So if I have a look at this kubectl login, it's very much similar to what we did previously in the slide. I provide my password, and now I'm logged in. If I now look at the context, you can see that there are 2 different contexts. One is the namespace and one is the overall supervisor cluster. So just to show you that I'm working at the supervisor level, you can see the 3 nodes that make up the supervisor cluster there. When I query the nodes, I don't have any virtual machines, but I do have lots of images that I can use in order to build virtual machines. I also have a number of classes that I can use. And again, Frank has covered those classes with us in detail in the initial part. Here's my manifest file for creating my guest cluster. This one is going to have a single control plane, but it's going to have 3 workers, and it's also going to have a Kubernetes version 1.18.10. If I look at the size or the class, you can see how many CPUs and how much memory is being allocated to each of these virtual machines or nodes in the cluster. So one more look, and now we'll just apply that, that particular manifest to create a guest cluster. Okay, so that'll take a little bit of time again. There are various objects that we can query from within the namespace with kubectl. And there we go. We can see it's in a creating state with one control plane, 3 worker nodes, and the distribution matches what we placed in the manifest as well. So this again takes a little bit of time. You can see the objects rolling out in vSphere. It's really good for a vSphere administrator, this, because you can see exactly what your developers are doing with your vSphere resources. Again, I'm speeding things up here a little bit, so we should see things start to fill in. All these add-ons are essentially all the different drivers for networking and storage and so on. But again, I can speed things up and they should all fill in. And you can see them all filling in there now. So yeah, so we're using AN3 as our networking interface. We're using our CSI driver from vSphere as well. And at this point, we should start seeing some virtual machines. You can see them there, and probably see them out in the I think we're ready to go, and we can see it all filled in here now in the UI as well. So that is how I create a guest cluster. But now, how do I interact with that guest cluster? We can see it's consuming resources in the namespace, but now I want to go and create pods and PVs and services. So what I'm going to do is I'm going to leave my current context, which is essentially at the supervisor namespace level, and I'm going to drop into the context, which is that guest cluster or workload cluster. And I do that with just a couple of additional command line options, which specifies the namespace and the name of the cluster. And so once I've dropped in here, providing credentials once again, I'm now working at a new context. Previously, I was working at the context of Cormac-NS, the namespace. Now I'm working at the TKG guest cluster context. So now anything I do here, and I can query the nodes, I should see that rather than seeing the 3 master nodes that I saw previously, which was the supervisor, I'm now looking at the nodes of the guest. And your developer can work in here then creating nodes, pods, sorry, not nodes. I suppose they could scale out nodes if they wish, but pods, stateful sets, deployments, all of that typically Kubernetes object related stuff. Okay, so let's, I think I have one last thing to show you. Yeah, so I'm going to finish one last item. It's the vSAN data persistent platform, which is also available with vSphere with Tanzu. And so what this is the ability to deploy out instances of services on a per namespace basis for your developers. Now, this became available with VCF 4.2. This does require VCF and NSXT, by the way. There's a requirement on that at the moment. But essentially, consider an environment where there are multiple developers, multiple teams of developers, and they're looking for an on-prem service. To begin with, we're providing S3. There are a number of options here from Minio, from Cloudian, and coming soon we'll have ECS from Dell EMC. But the whole idea here is that we'll be able to instantiate on a per namespace basis an instance of an S3 object store that your developers can use on a per namespace basis. So completely isolated from all the other S3 instances that you might instantiate, and just allocated on a per developer or per teams of developer basis within the namespace. Now we're able to instantiate this in a number of different ways. You can provision it directly onto vSAN as we know it today. And so you can provide it with what's called a shared knotting architecture, which essentially is deploying it with no protection at the vSAN level. There is a new configuration called vSAN Direct, and the vSAN Direct configuration allows you to provision instances of this service directly onto native devices. So an SSD device directly onto SSD or spinning disk, or even NVMe if you so wish. So that would bypass the vSAN data path and just use these devices directly for, let's say, optimal performance, if that was what you were looking for. So yeah, something that's a very recent announcement, only came out with VCF 4.2, let's say a couple of months ago at the most. And at the moment, we do have Minio and Cloudian S3 already available, Dell EMC coming down the line, and perhaps more third-party plugins as we go forward. So hopefully that's an interesting one for you. So that's it from me. Thanks very much. I'm going to hand you over to Duncan now.
There's one question, Cormac.
Yeah, sure.
So Bilal asked, what happens if HAProxy is lost? Do we lose connection to all namespaces and the services on Tanzu?
So that is a good question. I think the answer is yes. I think the answer is yes, because it is the HAProxy that is responsible for providing those. Yeah, I don't think anything gets plumbed. You know, I would actually have to try it. I would have to try it to try and see what would happen. I believe there is a dependency on the HAProxy. You certainly wouldn't be able to provision any new load balancing services or any new clusters, but it's something I would have to try, Bilal. So yeah, feel free to ping me. I should be able to do a test in the lab and see what happens there.
Yeah,
Okay.
I think it's also fair to say, Cormac, that from an availability perspective, we would expect customers to actually adopt NSX, right?
Yes,
instead of using HAProxy.
Yeah, or the NSX Advanced Load Balancer. Really, the HAProxy is just kind of proof of concept.
Exactly.
I would think in particular, we would want customers, yes, you're right, Duncan, either the NSXT or the newer NSX Advanced Load Balancer. Yeah, the HAProxy was a sort of, I guess, a sort of stopgap in between those two products being available.
And very useful for those who want to do a home lab or, you know, just play around in the lab.
Exactly.
Awesome.
Thanks, Cormac.
Sure. Cool. Okay. Well, there may be some questions in the chat as well that where you may want to add, you know, some additional color, Cormac. But for now, what I'm going to do is I'm going to finish the roadshow. First of all, I would like to thank everyone for attending. You know, a great number of people, but even more important, a lot of great questions. So keep those questions coming. In the upcoming 30-35 minutes, what I'll be doing is I'll be discussing what we have available from a vSAN perspective to make your life a bit easier when it comes to deploying these cloud native services. Now, of course, this doesn't only apply to cloud native services. This will also apply to traditional workloads. So all of the features that you will see in my presentation, of course, will both apply for cloud native workloads as well as for traditional workloads. And if there are particular caveats, you know, some features may or may not be supported, then I will either call them out, or, you know, Cormac or Frank may call them out in the chat as well if there are any specifics. And when we started talking about these types of solutions, I think the one thing that is very interesting is that when you start talking with cloud native folks, DevOps people, SREs, or, you know, whatever title that they have, they typically tend to talk about legacy applications as three-tiered solutions. And it's also something that people have referred to from an architectural perspective. When they talk about legacy architecture, they talk about three layers. Now, the one thing that I think is interesting is that if you look at what we've just been talking about for the past hour and a half, there are three distinct layers again. We're not talking about three distinct layers from an architecture perspective, but we're actually talking about it from a persona perspective. Because Frank primarily talked about what the developer consumes, and the developer primarily consumes Kubernetes as a clustering services and uses that to deploy his applications on top of, and then Kubernetes, of course, will do the scheduling. Then Cormac more or less addressed what the Kubernetes administrator or the DevOps team would be responsible for, which is basically making sure that that Kubernetes framework is available, plus also, of course, on top of vSphere, ensure that we have these cloud native services enabled, things like cloud native storage or the vSAN DPP platform, which will basically then enable customers to start deploying these applications while, of course, leveraging persistent storage. Now, the last thing which I am going to address is the infrastructure side of things, and then primarily the vSAN side of things. So as I've already mentioned, and as Cormac also has mentioned, these cloud native applications, of course, need to land on top of something. From a compute perspective, of course, they will be running within a Kubernetes cluster. The Kubernetes cluster in our case will run on top of vSphere. And then, of course, from a storage perspective, from a persistent volume standpoint, which is what Cormac addressed, these systems will need to be stored somewhere as well. And that is where vSAN comes into play. Now, for those who haven't seen vSAN just yet, vSAN is an enterprise level storage solution. And the great thing about vSAN is that it provides storage capabilities from a clustering perspective. So if you go to a cluster level, if you know where to enable HA and DRS, you see an additional option. That option is called vSAN. And on that option, you can now enable vSAN itself. And as soon as you enable it, what it will start doing is it will start grabbing all of the local storage devices. So these are locally attached disks or flash devices, just to, be sure that people understand what we are talking about. SAS, SATA, NVMe, PCIe, any of those types of devices. If you have those devices and they are part of our compatibility list, what will happen is that a single shared data store is going to be created. And then as soon as you have that shared data store, you can start provisioning virtual machines, maybe file shares, or deploy your cloud native applications on top of vSAN. Now, the interesting part here is the following. It's not the fact that we use these local devices, but it's actually how we enable you to manage your virtual machines, your VMDKs, or potentially, for instance, your file shares. When you deploy a virtual machine, or when you create an iSCSI LUN, or when you create a file share, you will need to associate a policy with it. As soon as you associate a policy with it, what is going to happen next is that vSAN is then going to provision the data, that virtual machine, that file share, that container, in the way you specified within that policy. If you specified, for instance, within the policy, and let's just take a look at an example. If you specified within a policy that you would like to have 2 full copies of the data, which is a RAID 1 mirror, then what will happen is that vSAN will ensure that you will have 2 copies of the data, and it will create a third witness component as well. And the witness component is basically there as a quorum mechanism. So if anything happens to one of the 2 data copies, that witness component can help determining which host still has access to the data. And that is basically what vSAN allows you to do, or what vSAN enables you. Of course, we have more capabilities, right? Not only can you specify within a policy that you would like to have 2 copies of the data, but you can specify that you would like to have a RAID 5 or a RAID 6 configuration. Or maybe you would like to stripe the data. There are all of these capabilities available within the policy that you can specify. And then, of course, as mentioned, when you apply to it, vSAN is going to distribute the data as you specified within that policy. Now, the great thing here is the following, right? If over time, for whatever reason, your requirements change or the requirements of the application owner changes, you can simply select a new policy, and then vSAN is going to automatically redistribute the data as specified within that policy. Now, this of course also applies to these cloud native workloads. When Cormac and Frank were just talking about the cloud native workloads, and they were talking about leveraging our storage policy-based management framework, you can do the exact same thing, right? If a developer deploys his application and over time he feels that RAID 5 would be, sufficient enough for that particular virtual machine, or he would like to see a RAID 6 configuration, they can actually select a different policy. And then at the back end, you will see those changes happening. Now, besides being able to specify within a policy what needs to happen to virtual machines, of course, on top of that, you can also enable certain data services on a per cluster level. And I think this is also something, that shows the true power of simplicity. I'm going to show you a demo later on where we actually, step through some of these different things. But enabling different data services is extremely easy when you use vSAN. It's typically, maybe 1 or 2 clicks. For instance, in vSAN 6.2, which is probably already 4 or 5 releases ago, we introduced deduplication and compression. We also not too long ago released data at rest encryption as a data services. On top of that, we also have vSAN iSCSI target service. And of course, in vSAN 7.0, we introduced vSAN file services. Most recently, on top of that, we also introduced data in transit encryption, and we introduced compression only as a data service for customers who have workloads running which don't deduplicate well. So in that particular case, you can select compression only, which will be a bit more efficient in terms of how it uses resources from a compute perspective. So for those customers who have workloads that don't dedupe well, but they can benefit from compression, make sure to select compression only, starting with 7.0 update 1. Now, the other thing that is available within vSAN is the ability to specify within the UI more or less what your data center looks like. So you'll have the ability to specify, for instance, that you have an X number of racks. So let's say you have 4 racks as shown here in this diagram. So you can create these 4, what we refer to as fault domains. And then you can specify which hosts are part of which fault domain. Now this adds, an additional level of availability, because as soon as you now start deploying a virtual machine, vSAN is going to ensure that you will have objects placed across those fault domains. So in the case where you actually have a full fault domain failure, so in this example, a full rack failure, or maybe the top of rack switches have failed, if that happens, your data is still going to be available because vSAN will actually spread the data as specified within the policy across those 3 racks. In this case, you see the exact same RAID 1 configuration again, 2 data objects, 1 data object in rack 1, 1 data object in rack 3, and then there's that witness component in rack 2. So if rack 1 fails, the data will still be accessible because the witness exists in rack 2 and the data exists in rack 3. So that is a great benefit of vSAN. Now we not only use that fault domain technology for racks or maybe even data center rooms within the same building, but we can also leverage the exact same technology to create a stretch cluster configuration. So if you have multiple data centers on the same campus or maybe within the same city, you can use vSAN stretch clustering technology to create this stretch cluster. So what I would like to do next is show you how you can create a vSAN cluster. What I'm going to do in this demo is I'm not only going to create a vSAN cluster, but this is going to be a stretch cluster. So I'm going to have 2 nodes in location A and 2 nodes in location B. And of course, I will also need to have a 3rd location that will act as a witness. Now, I already have a data center available here, and I have 4 hosts that are in maintenance mode in my data center, and there is another host in my data center, which is going to act as the witness. So what I'm going to do now is I'm going to create a cluster object. When I create a cluster object, of course, I will need to enable the different services. So those services are going to be DRS, HA, and vSAN. And then after I click next and I click finish and my cluster is going to be created, I will be taken automatically to this new wizard called the Quick Start wizard. The Quick Start wizard will then allow me to start adding hosts to my cluster, new hosts that still need to be introduced to vCenter or existing hosts. Now, I'm just going to pick existing hosts. So after I've done this, my cluster is going to be created from a vSAN perspective. However, of course, we still need to enable some of the different services. In my particular case, I would like to make sure that I have a stretch cluster configuration. So the hosts have been added. The hosts have been validated from a compatibility guide perspective. If the time has been synced, now all of those different things will be validated before we can take the next step. And then when we take the next step, we can start configuring additional things. We could configure the network. Now, in my case, the network is already configured, so I don't need to do that separately. But I would like to create a stretch cluster. And this is what it takes. I select stretch cluster, and then I simply can click next. That's all that it takes to create a stretch cluster. Well, of course, not all, because we also need to create those fault domains. We need to specify which host belongs to which fault domain. And that's what I'm doing here. I'm going to move 2 of the hosts to the right side, and then we have 2 hosts on the left side as well. So these are my 2 buildings. And then I will need to select my 3rd building, which will act as that quorum mechanism. And after I've selected it, and I've claimed the disks for my witness, and I click next, next, finish, my cluster is going to be created. My vSAN data store is going to be created by leveraging all of the local disks that are part of my hosts within my cluster. My witness that I've selected is going to be connected automatically to my cluster itself. And then when I now start creating new virtual machines, of course, I can ensure that my data is spread across 2 locations. So although I sped up parts of this video, creating a stretch cluster configuration with vSAN roughly takes probably less than 15 minutes. It's extremely easy. Now, I'm saying that the vSAN part is extremely easy. That doesn't, of course, necessarily mean that the networking part is easy. Of course, there's still a conversation to be had with the networking team. And I think Ahmed asks the right question: is there a specific network latency required for the stretch cluster creation? And there is a network latency requirement for stretch clusters. We tolerate at most, from a support perspective, 5 milliseconds worth of latency between the two data locations, and then up to 200 milliseconds worth of latency to that witness location. So you could, for instance, have a witness running, in a public cloud and environment that one of the partners offers. That is something that you could, for instance, do, because then you would have the ability to tolerate a bit more latency. But that's literally all that it takes. So 5 milliseconds worth of latency between the two buildings from a data perspective, and then 200 milliseconds at most to that witness location. Now, of course, besides being able to create a cluster and create virtual machines and deploy containers, etc., you also need to have the ability to grow your cluster. With vSAN, that is pretty straightforward. When you create a vSAN cluster and you would like to expand it, what you will need to do from a vSAN perspective is simply add new disks or flash devices to your hosts that are already part of the cluster. Of course, you can add a single disk, a single flash device, and add that to an existing disk group, or you can add multiple disks to an existing and create an additional disk group, or you can even add multiple hosts to an environment as well and add additional capacity from that standpoint. So you have different way of scaling your environment. Now, we've been able to do that since the very first version of vSAN, which was released in 2014. And you can imagine that since 2014, some of our customers have been asking, if it's possible also to start sharing capacity between vSAN clusters. And that is actually something that we've released in vSAN 7.0 Update 1, and we refer to this feature as HCI Mesh. And basically what HCI Mesh allows you to do, or enables an administrator to do, is to mount a remote data store across different clusters. So if I have a data store which has a lot of disk capacity available, I can mount this to some of my other clusters. And then when I create a new virtual machine, I can actually start leveraging the capacity on that remote data store. Of course, the added benefit of creating this mesh of vSAN clusters is the fact that I can now also start vMotioning virtual machines around that are stored on one of those data stores which is mounted. So as long as those data stores are mounted, I can just vMotion the virtual machine around, and I no longer need to storage vMotion the virtual machine around. So that is something that we've introduced as part of 7.0 Update 1. Now, for those who paid attention, I did mention briefly that this is possible between vSAN clusters. But what if you have a vSphere only cluster, a cluster that doesn't have vSAN enabled? Well, starting with vSAN 7.0 Update 2, we also introduced to you the ability to start sharing vSAN storage with non-vSAN based clusters. So if you have a compute only cluster, a cluster which is only running vSphere, if you have 7.0 Update 2, you can simply go to the UI and start mounting the data store and start consuming the data store as well. But besides talking about it, let me just show you what that looks like, because I think it shows the true power of vSAN HCI Mesh. So in this particular case, what I have available is a vSAN cluster. The vSAN cluster, of course, already has vSAN enabled. And what I'm going to do in this particular case is I'm going to go to my compute cluster. And then on my compute cluster, I'm going to click Configure vSAN. And when I click Configure vSAN, what I'm going to do is I'm going to select the compute only HCI Mesh option. So I'm going to select the bottom option, vSAN HCI Mesh compute cluster. And then when I click Next and Finish, the vSAN client is going to be loaded on my compute cluster. After the vSAN client has been loaded, what I can then do is I can simply mount my remote data store. So I can click on Mount Remote Data Store and mount the data stores that are available within this vCenter server. So only within this vCenter server for now. And I just see a question popping up if we will be able to do into vCenter server mounting. At this point, that is not possible. As you can imagine, it is a use case that we may be able to provide in the future. So hopefully that is something that we will be able to provide pretty soon. So here we are mounting that remote data store. I'm going to click Next, Next, Finish. The data store is going to be mounted, and after the data store has been mounted, what I can simply do is start provisioning my virtual machines. So when I provision a virtual machine, of course, what I will need to do is I will need to select the data store that the virtual machine needs to be provisioned on top of. So that is what I'm going to show you now. I'm going to select all of the default settings for the creation of the virtual machine. And then when it comes to storage, I can simply select my remote data store. I don't have a local data store. I just have the remote data store. I could even select the policy. So if I would like to have a RAID 5 configuration versus a RAID 1 configuration, I could have selected that policy as well. But for now, I'm just going to provision the virtual machine. And then after the virtual machine has provisioned, I'm going to click on the virtual machine and show you that from an operational perspective, within the UI, we of course also show you that this virtual machine has been provisioned on top of a remote data store. You can go to monitor, and then I go to physical disk placement. And as you can see, it shows me that it's remotely monitored. Now, the last thing that I briefly want to show you is one of the additions that we introduced in 7.0 Update 2 for policies. Because now that we have the ability to actually mount remote data stores, you can imagine that we also need to ensure when we provision virtual machines that certain data services which are enabled on a data store level need to be enabled for my workloads. For instance, if you have virtual machines which need to have encryption enabled, you can specify that within policy as well. So you can select data at rest encryption. If, for instance, you would like to have the workloads to be compressed, you can specify that. And of course, when you select compression, you also need to select all flash because that is only available in the all flash tier. So now when you have this policy selected and you provision a virtual machine and you select this policy for that virtual machine, only the data stores that will have compression enabled and that will have encryption enabled will show up as compatible data stores. And of course, that also applies to your container technologies. And that was basically what we had for HCI Mesh and the ability to start sharing vSAN storage across different environments. Now, we already had a question around the ability to share HCI Mesh into vCenter server. As I mentioned, it's not possible today. And there are a couple of other design considerations they need to take in mind as well. For instance, one of those things is that a single data store can only be mounted by a maximum number of 128 hosts at the moment. So if, for instance, you would have 5 clusters of which you would like to share the data store, now that is something that we support at most 5 data stores to be shared. But keep in mind that in total, those 5 clusters also need to have less than 128 hosts within those 5. So that is something to keep in consideration as well when it comes to HCI Mesh specifically. Now, talking about the different use cases, Cormac has already mentioned persistent volumes. One of the reasons vSAN introduced vSAN file services, of course, was for cloud native workloads. Of course, not only for cloud native workloads, because other types of workloads besides containers can also benefit from either NFS or SMB storage. In 7.0, we introduced vSAN file services. And in 7.0, specifically, we introduced support for NFS version 4.1 and version 3. And then in 7.0 Update 1, we introduced support for SMB version 2.1, SMB version 3, and on top of that, authentication through Kerberos for NFS and Active Directory for SMB. And I should probably say that, if you're one of those customers that is already using 7.0, make sure you either upgrade to 7.0 Update 1, or maybe even to the latest version, Update 2, of which just a patch was released even a day ago. So yesterday there was a new version for vCenter server. You may want to look into that if you're one of those customers that is running the latest version of vSphere. Now, of course, we also introduced some additional changes for vSAN file services in 7.0 Update 2. With 7.0 Update 2, we now also support the use of vSAN file services on top of a stretch cluster configuration. Now, you may ask yourself, why wasn't this supported in the first place? Well, the reason was pretty straightforward, right? In the past, when you were running vSAN file services, or with 7.0 and 7.0 Update 1 specifically, there was no way of specifying through which a particular IP address or DNS name should be accessed or could be accessed. So basically, you could end up in a situation where you would have a virtual machine accessing an NFS share. That NFS share was in the secondary side, while the workload itself is running in the preferred site. So you would also always incur the latency between those two locations. And this is one of the reasons we introduced the ability to create what we call site affinity from a vSAN file services perspective. And this then basically allows you to start aligning your workloads with the file shares itself and with the IP addresses, I should probably say, of the file shares, because the file shares will be available in both locations through the policy, of course, that you've selected. But then the IP addresses will be located in one or the other. Now, I was just going to show you in a demo what that looks like, because I think it probably makes things a bit more easier. Now, before I do, I briefly want to go over the architecture just so you have a better understanding of what it looks like. Now, when you have an NFS client or an SMB client, it typically connects to an NFS server or an SMB server. This NFS or SMB server, of course, runs on top of vSphere. Now, in this particular case, there's something unique here because we didn't introduce this service as a kernel service, but we're actually running it as a container within a virtual machine. Very similar to all of the container technologies that Frank and Cormac were talking about. So it's a similar approach. Now, the deployment of these virtual machines and these containers are done by vSphere itself. So it's ESX Agent Manager, which has been part of vSphere for over a decade probably, which is responsible for deploying these virtual machines. When you create a file share and you select the policy, it then is vSAN, which is responsible for creating the objects in which that file system will reside. So as soon as those objects have been created, those vSAN objects, a virtual distributed file system is going to be laid out across all of these components. And that virtual distributed file system is then going to be exposed as NFS or SMB to the client connecting. So hopefully that kind of makes it clear what the architecture looks like. Now, some of you may wonder, right, if this has been implemented as a container technology or a virtual machine technology, is it still efficient? And I have to say it's highly efficient. And the reason for it is that we use this special interface, the vSocket or VMCI interface, as it was called back in the day, which basically is a PCIe device, which has the ability to connect applications directly to kernel modules that reside within vSphere. So it's a highly optimized path from an IO perspective point of view. Now let's take a look at the demo. So what I'm going to show you right now is how you enable vSAN file services in a stretched cluster configuration. And then of course, I will show you how you can create file shares on top of that. Now in this particular case, I have an 8-node cluster. And I already have vSAN enabled, and I also have already created a vSAN stretched cluster configuration. All of the hosts that end within the 30s range are part of the preferred side. All of the hosts that end with the 40s range are part of the secondary side. So what I'm going to do in this particular case is I'm going to enable vSAN file services. I simply need to click enable, and then I'm going to step through this wizard. Within this wizard, I need to do a couple of things. First of all, I need to specify a file services domain name. This is basically a namespace construct for vSAN file services itself. Then I will need to specify a DNS server and of course a DNS suffix. The next thing that I will need to do is I will need to make sure that my environment is connected to the network. So we'll need to select a port group. Make sure you create a dedicated port group for this, because the port group that you will have selected will get promiscuous mode and force transmit automatically enabled. Then of course, for that particular port group, I will need to make sure that I select the right subnet mask and the gateway, and then I will need starting IP addresses. Now, just to make sure that people understand what is going to happen here, these IP addresses that I specify are going to be assigned to the containers that run within the virtual machine. These IP addresses are not going to be assigned to the virtual machines itself. So when you look at the virtual machine, when you click on the virtual machine, you won't see a IP address assigned to that virtual machine. But if you go into the virtual machine, you will see when you use the Docker commands that the IP address has been assigned to the file services container. So this is something that I think is important to understand. And this is also the reason, by the way, why we need to use promiscuous mode and forced transmit. Now, we provide all of the IP addresses for the different file services that containers that will be running in my environment. I will click on lookup DNS because I've already added all of the details to DNS. And then per IP address, I will need to specify in which site my IP address will need to reside. So I will select preferred for the first 4 and then secondary for the second 4. So now what is going to happen when I click next, next, finish is that 8 virtual machines are going to be deployed. And within those 8 virtual machines, I will have 8 containers instantiated. These 8 containers will have the IP addresses associated with it that I've just specified. And of course, the IP addresses will reside within the location that I specified as well. So if you have a virtual machine running inside A, and you select IP address A to connect to, it will of course, you will of course have the traffic only going to that particular location when it comes to read. Now, next thing I'm going to do is I'm going to create a file share. When I create a file share, of course, I will need to specify the policy. As you can see, the policy selected a stretch clustering policy, which is a RAID 1 configuration across locations. And then it's additionally going to be protected within the location as a RAID 1 configuration as well, which means you basically have double protection in this particular case. Then, of course, the next thing that I will need to do, as mentioned, I will need to specify the affinity for this file share as well. So I'm going to specify the affinity for the file share. It will have affinity with the preferred location, which means that it will get an IP address associated with this file share, which resides in my preferred location as well. So basically, this will allow me to have applications running within my preferred location that will then get local access to my virtual machines. Now, when my file share has been created, I can start inspecting the file share. I can already look at some of the details, of course, in the UI straight here. It shows me which site it has affinity, the policy that has been associated with it. But I can also click on the details pane and then look at how the data has been distributed. I can see that we have multiple RAID 1 configurations, not just in the 30s range, but of course also in the 40s range, because the data has been spread or stretched across 2 locations. So even if one of the locations fails, this file share is still going to be available. And I think that is something that, you know, not only shows the power of vSAN, but also shows you how easy and how simple it is to use, and you know the efficiency that it will provide as well from an operational perspective. One other thing that I would like to point out, of course, as soon as you tick the tick box next to the file share itself, you will also have the ability to copy the URL. So it will provide you the path to the file share itself, both for NFS version 4.1 as well as for NFS version 3. Now, the last thing that I want to talk about before we're going to wrap it up is all around management. And it's one of those questions that keeps on coming up fairly frequently. And this is how you do performance monitoring around vSAN-based virtual machines. Now, we've had this fling out for a while, and this fling is called vSAN IO Insight. And basically, for those who don't know what a fling is, it's an engineering project which is not officially supported by vSAN, by VMware itself. Now, what we've done in this particular case, because we had a lot of great feedback on this particular fling, is we've introduced this fling as an officially supported feature within the UI. So in the UI, you now have the ability to go to a virtual machine and right-click a virtual machine and start tracing that virtual machine from an IO perspective to figure out what it's doing. It's probably easiest if I just show you what that looks like, because that instantly shows you how easy vSAN IO Insight is to use. I can either right-click my virtual machine or right-click my cluster. And then when I click on vSAN, I can click New IO Insight Instance. When I select New IO Insight Instance, I can select all of my virtual machines running, or I can select one of my virtual machines. Now, in this case, I'm going to monitor my vSAN the server environment, and I can monitor for it for an X amount of time. I'm just going to monitor it for 10 minutes, but I could also do it for 24 hours if that is something that I would prefer to do. Now, of course, when it's running, I can actually go to the monitoring section. And if I go to the vSAN section and under vSAN, I go to performance, I now see a new option, which is called IO Insight. On the IO Insight option, when I click that, I now see all of the instances for which I am tracing performance. So I started it for my VCSA, and as you can see, my VCSA instance pops up. It's going to be running for another 9 minutes, so we'll speed up this part of the video, and then as soon as it completes, what we will be able to do is we can inspect the data. We can rename, for instance, the instance to a name that makes more sense. We can delete it, but we can also rerun it. So if I would like to rerun it for whatever reason, I could also do that. In this particular case, I just want to show you what kind of data it captures. And as you can see, it captures a lot of data. It shows you the number of IOPS, the throughput, whether the IO is sequential or random, what the ratio is between sequential or random, what the read-write ratio is, whether the blocks were 4K aligned or not, what the IO size distribution is, and even the IO latency distribution. So an extreme amount of useful information for customers who would like to do more advanced or in-depth troubleshooting available with IO Insight. Of course, not just for the first disk, but we have that available for all of the disks that are part of the virtual machine or of the virtual machines that you're tracing. Now, having said that, I can imagine that some of you may wonder where this is heading towards next when it comes to this particular feature. And one of the things that we are now exploring is providing you the ability to get even more insights when it comes to the IO trip itself. Now, we've just seen how you can enable the tracing of that virtual machine. And you can imagine that we could do something similar when it comes to analyzing the trip of the IO itself. We can provide all of the data, but I think it's probably going to be more useful if we transform that data into a diagram, and the diagram basically shows you from the virtual disk all the way down to the capacity tier, what kind of latency is introduced on every single layer. This is something that we don't have available today, but this is something that we are considering for a future release of vSAN. And with that, we've reached the end of my part of the session. I think I've already answered most of the questions. I'm not sure if there are any other questions that people would like me to answer. If there are any other questions, feel free to answer or ask the questions in the chat. Of course, if there are no other questions, I'm happy to give it back to the VMUG team so we can wrap it off and call it a day. Thanks, everyone.
Thanks, Duncan. Thanks, Frank and Cormac. It's really very informative, and I'm sure from that type of question what the team was following an interest, and definitely will follow up with anyone need more clarification or answering any question. Hopefully, this will be our last virtual one. Looking forward to see you physically maybe next year in Egypt. We'll be happy to host you and maybe offer you a visit to the pyramids.
Nice. Sounds great.
Thank you.
Sounds good.
Yeah, sure. Promise. Thank you, team, and wish you a nice evening. Yeah. Thank you, everyone.
Hey, everybody.
Bye-bye.
Thanks, everyone.
Bye-bye.
See you. Bye-bye.